Okay, the last lesson was super tedious, and you probably had to go back over it a couple times if you really wanted to get it down. This one is kind of the opposite of that. We're showing you a couple of ways that these things are used in everyday life. Now, a lot of times, sound is measured in frequency. And I know that you've heard this before when you talk about frequencies of sound. Low frequencies sound very low, high frequencies sound very high pitched. And what do those actually mean when you say a frequency of, let's say, 100? Now, the way that this relates to the trig functions that we were just doing is that the period and the frequency are just reciprocals of each other. So for instance, if we look at this top bunch of words here, if the period of a function is 1 over 100, then the frequency is going to be 100 cycles per second. A way to write this out is that our frequency is going to equal 1 over our period, but we can also think of our period equaling 1 over our frequency. Either way works. So let's try that out with example A here. It says sound that has a frequency below the human range is known as infrasound. Elephants can hear sounds in the infrasound range with frequencies as low as 5 hertz or 5 cycles per second. So find the period of the function that models the sound waves. So they give us the frequency. We need to find the period. So if it's just going to be reciprocals of each other, then our period is going to equal 1 over 5 because the frequency was 5. So period here is going to be 1 over 5. Now, for the B portion of this, it says let amplitude equal 1 unit. So our A is going to equal 1. Write a sine equation to represent the sound wave y as a function of time, and then graph the equation. So a couple things to note here is that we're going to have y equals something sine of something, right? And instead of using theta, we're going to use t because it's a function of time. Now, the first thing we're going to say is we're going to say y equals a for amplitude sine of b times t. Usually instead of t, we would write theta, so we're just going to keep t in this instance. A equals 1. We know that for sure. We're going to say y equals 1 sine of bt. So what are we going to place in for b? Now we have to write out the equation that we knew beforehand. Let's deal with degrees because I know that everybody's a little bit more comfortable with degrees, but you could also use radians if you want to. Now to figure out b, we're going to have to do something a slight bit fancy. This comes from the equation that we know before, as our period is going to be 360 degrees over our b value. So basically, we know exactly what our p equals. Our period equals 1 over 5, and that is going to equal 360 over b. So we just need to solve out for our b value, and we should be able to just place it into our equation. The easiest way to do this is just to cross multiply across this equation, and we'll get b on one side, and on the other side we're going to get 360 times 5. So b in this case, or what we're going to put in there, is going to equal 1,800. Now, if you notice, that is a big number. So I'm going to use my radian measures, and I'm going to show you how much simpler this actually is. I'm going to put this in the I don't want to deal with that right now section and make a new box, but with radians instead. So my period is going to equal 2 pi over b. Again, I already know that my period is going to be 1 over 5. So we're going to take 2 pi over b and we're going to solve for b. The easiest way of doing this is still to cross multiply. But once we do this, this is going to be b equals 2 pi times 5, which we would know to be 10 pi. I like that a little bit better than the other one because my b being 10 pi is so much easier to deal with than 1,800. You can use either, but that is what's going to go into the place of b. So we're going to say 10 pi times t, and this is the end of my equation. Y equals sine of 10 pi t. Now give this a shot. Humans can hear the sound with frequencies as low as 20 hertz. So we want to find the period of this function, but instead we want to write this as a cosine equation instead. Pause the video and press play when you are done. Good job on pausing the video. So we're going to try this out. If the frequency is 20, that means the period is going to be 1 over 20. So let's try and build a trig function that models this. Now we're going to be using cosine this time, so we're going to say y equals cosine. The amplitude is 1, so we don't have to deal with the amplitude here. Cosine of b times t. Remember, we are using t instead of theta here. So we need to figure out what do we place in place of b. So we remember that our period is going to equal 2 pi over our b value. So now we're going to replace p, or our period, with 1 over 20 because we know exactly what it equals already. This is going to equal 2 pi over b. Again, the easiest way to solve this equation is just to cross multiply. That is going to leave us with a b value of 2 pi times 20, or a b value of 40 pi. So 40 pi is going to be going in place of our b value. So our finalized trig function is going to equal cosine of 40 pi t. I'm pretty sure.